don't come through.
Okay, the stream has started, so we're live on the internet. The show hasn't started yet, but we're live on the web. So let me go do my usual distribution model on Facebook. Gentlemen, we have a distribution method here where I share the stream to different pages on Facebook. Basically, if you're a broadcast engineer, you can't avoid the show. So,
Like a multicast.
Yep.
Well, we just share the stream out to several places. My personal place and
on your website, you can't. Can you watch it live on your website, or is that just a repository? I mean, on the TWiRT website, that's just a
the TWiRT website. You can't watch it live there.
Right.
I post the finished product there, but you can watch it live at that link that you found for YouTube. Yeah.
Oh, okay.
Yeah.
Mm-hmm.
Yeah, that's true.
Right.
All right.
I got to close my Outlook here.
Oh yeah, all that unwanted noise.
Yeah. I gotta go get my hair just right.
And I know it's time. I'm still sharing this to the TWiRT Facebook page. Okay. Okay. Almost done. There we go. Okay. I know. I should, but well, that applies to so many things, like putting out the trash. Why can't I just say, "She who shall not be named," take out the trash, or
then
put away the Christmas decorations?
Yeah, you'd have even less chance to meet your neighbors.
Yeah, the easy button. I've got an easy button around here somewhere. Okay, and Reggie, I don't know if you noticed, but I got a summary of our meeting at lunchtime today.
Oh, very good.
And of course, Gemini spelled your name wrong every single time, so I went through and mass corrected it.
That's never happened before, Reggie. Right?
All right. Okay, I guess we are ready to start. Hey, everybody on the network watching us live. This is the part of the show that gets cut out because this part gets replaced with a bona fide recorded intro where we mention the sponsors. Speaking of sponsors, thank you for patronizing our sponsors. I appreciate you giving them the business when you need to give somebody the business. So that's great. I really appreciate that, and so do they. And it helps us pay the bills because some people around here get paid. Well, that would be Suncast. I don't know about the rest of us. Let's see here. Oh yeah, the internet company gets paid. All right. Not sure if Chris Tarr is going to show up. So far, he hasn't. So maybe not. But we have almost a full house. So here we go. It's episode 738. So I'm ready. I've got my energy drink right here. Get the heart rate up. Get the blood pressure up. Maybe get the mind working. And I guess we're ready to start. Okay, we'll start the show in 3, 2. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. We've got a really fascinating topic today, something that I don't know a whole lot about, and I've been learning. And can't wait to find out more. I'm Kirk Harnack, the host of This Week in Radio Tech. We've done geez, this is our 738th episode, as I may have mentioned. So, wow, that's a lot. And we appreciate you being with us on so many of them. Has anybody been with us for all of them? I mean, besides me? Wow, that's anyway, really enjoy bringing broadcast technical information to you, my colleagues, my friends who are in broadcast engineering. I'm in the Nashville studio, sponsored by Telos Alliance. So thanks, Telos Alliance, for letting me take a couple hours off on Thursday afternoons to do this show. It's a beautiful day here in Nashville. The sun came out and it was just gorgeous. Maybe it's pretty where you are. A little bit chilly, but not too bad. Chris Tarr is normally with us at least half the time, but I don't think he's with us today. He got really busy at work today. So it's just me. And luckily we have two guests. So let's jump right into it. Our topic is about software-defined wide area networks, or SD-WANs. And we have a couple of experts here to educate us on that topic. First of all, let me bring in my friend, Dan Merwin. I've known Dan for a couple of years now. Hey, Dan, it's good to see you. Welcome in.
Likewise. Thanks for having me, Kirk.
Good. You are you're in the Denver area, is that right?
That's correct. And we have a sunny day here. Might get up to 50 degrees today, so not too bad.
You and our other guest, we'll bring him on in just a second. You have a number of skills outside of broadcast engineering. So you've done some broadcast engineering. You do some engineering right now, and you and I have spent some time doing some work together, building a radio station in Oxford, Mississippi. If you don't mind, what are a couple things that you enjoy besides romantic walks on the beach and sunsets?
Well, yeah, music is probably my main passion outside of broadcast technology, of course. I play guitar and bass and sing, and so I've always done that, and hopefully I always will. And mostly rock, folk, blues, reggae, a little bit of jazz, that kind of stuff. So,
wow,
yeah, that. And what's another interesting fact about me is that my wife is French, so it's the main language in our home. So, anybody needs someone to translate, ring me up.
I'm waiting to ask you a question during the show, and you're going to say, "Oh, I'm sorry, I forgot the English word for that."
Yeah, that happens.
So your kids are speaking French at home too? Yeah.
Yes. Yeah.
Wow.
When they were young, I spoke exclusively French with them. We wanted French to be the primary language because we knew the English would come anyway. And so, but now I speak. Yeah, now I speak English with my kids because it seems more natural. But my wife still speaks French with them. And
cool.
Our daughter lives in Paris. So yeah.
Oh wow, good deal.
Yeah.
Well, our other guest speaks English, but sometimes he's using polysyllabic words that I'm not sure I understand yet. So let's bring in Reggie Jeffrey. Reggie, hi, welcome into the show. It's good to see you.
How you doing? Thanks for having me.
Good. Glad you're here. Yeah. There we go. We see you now. Tell us a little bit about Reggie Jeffrey. What are you busy doing in the technology world these days?
Oh, yeah. So very busy these days. I am a solutions engineer for an organization called Intelisys. And so what I do is I'm a generalist SE. I help our team develop solutions around pretty much all of our tech stacks. We have 7 major ones. That includes everything from cybersecurity, physical security, network connectivity, software as a service, co-location, the whole 9 yards. So one of my specialties is SD-WAN and unified communications as a service and contact center as a service. So which you can just kind of wrap up as telephony. So that's where I'm coming in today, and hoping we can help each other out.
Well, good deal. Well, we had a lunchtime meeting with Dan and Reggie with the Nashville SBE chapter, and we learned about software-defined WANs. And I posed a couple of questions as to why is this necessary? Why is it helpful in most cases? Why is it maybe not necessary in a few other cases? And what are all the benefits here? And Reggie just kind of listed a whole stack of benefits and services that can file into SD-WANs. We're going to focus on this show about SD-WANs and kind of how they can help broadcasters. So the three of us together will discuss SD-WAN technology and how they can make broadcast operations, which has become so dependent on IP technology, how we can make that more reliable. We're going to get into the show here in just a minute. I want to, of course, bring in our very first sponsor, and that is our friends at AIR, AIIR.com. Here's a little chat I had with the CEO of AIR, Ricky Lee. Hey, it's Kirk Harnack, and I'm here with Ricky Lee, the CEO of AIR. Ricky, you guys make a fantastic automation system, but streaming is a really big deal. Tell me about streaming with AIR.
It really is. We've got a beautiful streaming platform with an incredible dashboard with fantastic analytics. And you can buy it for just $20 a month. All you can eat. No limits on bandwidth or bit rates. And you can also record shows as well. So if you like to deliver on-demand content for $20 a month, you can stream and deliver that on-demand content to an RSS feed that can feed your radio player, your mobile apps, or a podcast that people can download and enjoy.
Now, $20 a month, that must be for just some slow MP3, right?
No, MP3, AAC, and we also now support HLS, which is big in the industry right now.
Wow, that's pretty amazing. How do I start to explore or find out more about streaming through AIR?
You go to air.com, AIIR.com/streaming, and from there, with a credit card, you can sign up and get started.
I'm really enjoying our relationship with AIR, AIIR, and you have heard me say before, my radio stations are users of the Playout One automation system, and they have integrations in Playout One that make it easy to stream, really easy to stream on most any platform, but certainly easy to stream on AIR.com's streaming platform. Thanks a lot, AIR and Ricky, and everyone else, Dave Brierley-Jones and others, for sponsoring This Week in Radio Tech. All right, I'm Kirk Harnack in Nashville, and we're going to jump right into SD-WAN technology. Dan, if you wouldn't mind, kind of set this up, and if you wouldn't mind, introduce Reggie as he will jump into a technical explanation.
Yeah, absolutely. So my company is Broadcast Telecom, and so I've been in telecom my entire life. And got into broadcast technology kind of recently, but loving it. And so anyway, I set up my company, which is an agency that helps organizations source telecom and IP solutions, and IT solutions rather. And one of the if you know anything about the agency business, there are some master agencies that smaller agencies like myself go through to access the providers and to have additional resources like engineers and back office support. And so Reggie works for Intelisys, which was purchased by a company called ScanSource a couple of years ago. And Reggie is a sales engineer for Intelisys. And so he's got a lot of things to remember, because not only does he have to know all the technologies, but he also has to have some knowledge of all the different providers. And there are literally hundreds of providers out there in the marketplace that can provide the services that we can bring in. So Reggie's a smart guy. So without further ado, I'll pass it over to Reggie.
Thank you so much.
Reggie.
I appreciate the kind words. Well, thanks again for having me. I guess I'll just dive right into it. What is SD-WAN, or software defined wide area network? And essentially it is basically standard software defined as applications that go over the top of your infrastructure where you can actually have redundancy across your network. So let me break that down a little bit. So the definitions, the protocols, the procedures, the policies are done in the cloud on an orchestrator, and that instruction is given to an edge device that sits on location, as opposed to the device on location having all that information. So the advantage of that is I have a few advantages. So with the initial, I guess, creation of SD-WAN, The main advantage is that I can connect multiple ISPs or internet service providers to this edge device. And then the packet traffic going across those two ISPs or even three ISPs um, is controlled by the cloud orchestrator. So it can do things like load balancing. It can do things like packet replication. It can do things like automatic failover or quality of service, QoS as they speak of it. And it can do it seamlessly without having to write complicated netting tables, without having to write or have someone on service to a manual switchover, without having multiple pieces of hardware on site. Everything's done in the cloud on an orchestrator that a user could have access to. Very helpful in a scenario where you have multiple locations. I have 10 office buildings. I need to be able to deploy a network stack in those office buildings, but have a control from one central location. I can easily send an edge device or an SD-WAN edge device out there, plug it in the internet, and all the instructions come in from the orchestrator. It's very helpful if I want to have a high availability of internet. So, for example, at least in broadcasting, maybe I need to always be up because I have a 24-hour broadcast, or there's a weather incident. If weather knocks out my traditional ISP, I may have a cellular redundancy or a Starlink redundancy that automatically fails over to the other circuit or sends traffic down the circuit that has the least resistance without necessarily having the right instructions. And then the other advantage of it is I'm able to put different cybersecurity scenarios over the top of it. Zero trust network access. I'm able to do cloud separation. I'm able to do firewall as a service over the top. So there's a cybersecurity layer that goes over the top of that baseline SD-WAN infrastructure as well. So a real basic, high level definition of what SDN is and a little bit about where it came from.
Yeah, I'm
wow.
sure that.
Okay. Go ahead.
I was just going to say, I'm sure a lot of the listeners are probably familiar with MPLS, and one thing about SD-WAN is that it has replaced MPLS for a lot of customers, not for everyone. There's still a lot of MPLS out there, but you can use MPLS circuits with SD-WAN, so you can use internet and MPLS as a combination. So it gives people the flexibility to do that for
working at Telos Alliance, when we first came out with codecs that didn't really have error correction on their own, except what was built into the AAC algorithm, for example, we would tell people that you want to get an MPLS circuit. And this was frankly 15 years ago, when maybe internet was generally less reliable and there were maybe more points of contention. And so MPLS was something that got recommended a lot. In my job, I have not had to or felt the need to recommend MPLS circuits for broadcasters, because most of the time, not all the time, but most of the time, regular public internet, as long as there's not some known congestion problem, is good enough, especially if you have more than one circuit or more than one path, maybe more than one provider. And that's kind of what I'd like to set the stage a little bit for our conversation into SD-WAN technology. Broadcasters and broadcast equipment manufacturers like Telos Alliance or like other codec manufacturers like Comrex or Tyline, they oftentimes have developed a dual WAN technology on their product, so that if you're on remote, for example, you could have two 4G LTE gateways, or maybe you could have Wi-Fi from the gymnasium and a 4G LTE, and you would have two paths back to the radio station. Even better, if your broadcast facility, your radio station, your headquarters has more than one internet, even better, on more than one backbone. I've got a friend, one of our friends who's been on the show before, Dave Anderson, down in the Sarasota area. He now he's in Tampa. He's got he worked at a station that had 4 sources of internet at the studio, and each transmitter site had 2 different sources of internet. So using these multiple paths, and they were all consumer grade paths typically, that gave them more redundancy. And, if a path lost a packet or two or was down for half a day, they still had the other path to replace a packet or a bunch of packets or to be there on the air link. Now, so what I'm getting at is broadcasters have come up with some ways apart from standard IT networking, especially it's apart from SD-WAN, to solve some of these problems. But as I pointed out in our SBE meeting today, if I use these techniques, I may end up having a better reliability situation for an STL application, an IP STL. So I have some stations that have micro MPX technology, and we're using the Omnia MPX decoder node at the transmitter sites, and they can have two WANs connecting to them. But I'm not an IT guy as much as I'd like to be. So the only place where I've implemented dual WAN is for those particular pieces of equipment. And that means that I don't get the benefits of dual WAN or SD-WAN on the other things that are at the transmitter site that don't have dual WAN capability. So all this is leading up to say that by using SD-WAN, by implementing this technology, we may be able to gain some of the benefits of redundancy for all the equipment at the transmitter site or at another studio in a different city, things that we want to connect together. And not only do we gain that dual or multiple path redundancy, we gain it for everything that's there that we want to be on that, and we gain some other benefits as well, like really excellent traffic shaping and monitoring, sending particular packets through the best path that they want to go through for the best performance. And I don't mean to be opening up the whole can of worms here, Reggie, but I just wanted to kind of put this in context with what engineers like me know right now, and how we can then see that SD-WAN is not just a patch on this, it's a whole better way of handling our data between sites or among sites. So, Reggie, with that buildup, kind of tell me if I'm kind of on the right track with how I'm thinking about SD-WAN.
No, you're definitely on the right track. The way I try to explain it to folks who are just getting into it is, hey, I have a city. I've got a lot of traffic because my city's growing. I'm going to add more streets. Well, great, you've added more streets, but now you're still getting, latency or people getting to where they need to be slowly. So instead of adding more streets, now what I've added is traffic lights to all those streets. So now I can redirect traffic as need be. And now that I've got traffic lights on those streets, now that I've got someone monitoring those traffic lights and monitoring where traffic is going where, what traffic it is, and what time of the day it is. So to your example, we talked about redundancy. Yes, that is there. If one internet ISP goes down, I can fail over to another. But the other part of that redundancy, and to your point about, maybe I can configure maybe 3 or 4 WANs on the back of that firewall, but that's the key thing. You're configuring them. You're setting in rules, or you're setting in best lines, or most the best path or the shortest path to go to in a particular instance. And if an instance come across that doesn't meet that, it's just going to default to the information it knows. Whereas SD-WAN is, I don't want to say it's artificial intelligence, but it is smart and it is live. And it's following trends, and it's easier to configure, just in some cases by even talking to it with an LLM. So the other thing it's able to do is say, okay, this may be the shortest path, but it's not my DIA path, my direct internet access path. So yeah, this is the shortest path, but the guarantee of that packet getting there is not great. I'm going to send it down my DIA. Or maybe I have internal company traffic and I have an MPLS in mind. So I'm going to send it. I recognize the type of traffic that you're coming through from, and the recognition is coming from the orchestrator. The orchestrator says, go ahead and send this type of traffic down to MPLS because it's in place. We're doing a live broadcast. Use the broadband path for this IP trafficking. So it's doing that on the fly. It's doing that without necessarily, there's some configuration, yes, but it's very easy configuration. A lot of that configuration is a reflection of how you do business, not just X's and O's and ones and zeros and typing in script. That's done by the provider. So it makes it very scalable. It makes it very smart on what traffic goes down what pipe at what time. Yeah, if any of you notice that, maybe the internet is a little bit slower around the time kids get home from school and things of that nature, because everybody's on a broadband channel, that, that's the reason why it's broadband. So even though I've got speeds guaranteed to this, it may not be that speed at that time. Your SD-WAN understands that and says, let me send the traffic down this route because it may be longer, but the lane is cleaner and you'll get there safer and you'll get there guaranteed with packet replication however you want.
So we're talking to Reggie Jeffrey and Dan Merwin about SD-WAN. And we're going to take a quick break, but when we come back, Reggie and Dan, I'd like a little bit better picture in my head about the equipment that goes at the sites that we're interested in having on the SD-WAN. Are there scenarios where you don't have extra equipment at the sites, or is there always something extra there? And then I want to give you a particular scenario that is pretty common for what we do in broadcast. Let's say I'm using an IP link over the perhaps public internet to provide audio to a transmitter site and maybe some monitoring audio back. But I also want to do offsite backup of my automation system. In fact, I put an automation system at the transmitter site, and I can put it on the air remotely if I need to. But sometimes there's big dumps of data that go from the studio to the transmitter, and that's going to go over the same IP path. I want to understand how SD-WAN can help stop this backup of data going to the transmitter site from interfering with the real-time audio that I'm also sending on the same data pipe. So I want to understand how SD-WAN can perhaps prioritize the data so I don't go off the air just because my automation says, oh, I need to send you a whole bunch of music, So we're going to get to that coming up. This week in Radio Tech, I'm Kirk Harnack. We're learning about software-defined WAN technology, and especially as it might relate to us broadcasters. Our show is brought to you in part by Broadcast Bionics and something called the Virtual Rack. I realized we hadn't talked about Virtual Rack in quite a few weeks here, and I want to tell you about it now. For a few years now, we've heard about containerized broadcast infrastructure applications. So my employer, TELUS Alliance, makes some really cool products that are containerized, like the Forza audio processor, also like phone systems like the TELUS VXS, intercom systems like the TELUS Infinity VIP, and even an audio console, the Axia Altus audio console. Well, TELUS Alliance isn't the only company that's making containerized broadcast infrastructure products. And the folks at Broadcast Bionics, they thought, hey, why don't we make it easier to deploy these containerized products? Because I got to tell you, deploying Docker containers is not for the faint of heart, especially because there is some specialized networking that needs to be set up within the server that's handling this. And there's also limits on how much can I have this server do before it goes, I'm out of CPU power. Well, Virtual Rack is the product that takes care of that for you from Broadcast Bionics. Virtual Rack is a hardware product that you buy. They sell it in two different sizes. You get this server, and when you get it, you plug it in, you give it an IP address, and when you browse into it, it has, I guess, what you might call an app store of different broadcast products that are available to run in this from companies like Ferncast, Sound4, TELUS Alliance, 2WCOM. So you've got a variety of different infrastructure things that you can have in there. You pick the product or products that you want. Okay, I want 3 audio consoles and 3 audio processors, plus maybe some codecs from 2WCOM. Click install, and within a few minutes, they're installed. You give them IP addresses, the addresses that you want. They properly install automagically, and I mean it's automagically. The developers at Broadcast Bionics have really made this easy, reliable, and quite understandable. So I stood on the NAB floor last year and watched them do this, watch them install some Telos products in the virtual rack server. And wow, just amazing. Literally within minutes, you've got audio consoles, you've got a phone system, you've got audio processing for FM or for streaming or HD use. All that can go right in. And I don't know. It's really cool. You can deploy containerized products, as they say on their website, without being a Linux expert. It handles the details in the background for you. So I love this thing. Oh, you can also do have backup. You can have a hot redundancy, hot failover if you buy two of them. Get whatever you need to handle your broadcast facility. You can even handle this on an N+1 type of scale. It's virtual rack from Broadcast Bionics. If you go to this webpage on the Bionics website, in fact, maybe a Suncast, you could scroll down to the bottom. I hope they still have them there. They have there's 3 videos there that help explain this very well. And we even did a show, a This Week in Radio Tech show, where Dan McQuillan explained how virtual rack works and did a really beautiful job of it. So check out these videos or look for a previous episode of TWiRT where we talk about it. Thanks a lot to Broadcast Bionics, always innovating things to make our lives better and easier in the broadcast world. Broadcast Bionics at bionics.co.uk. I'm Kirk Harnack. It's This Week in Radio Tech, and we're here with Dan Merwin and Reggie Jeffrey. Dan and Reggie, we were let's see, I had a couple questions. Oh yeah, about help me visualize this. What when I deploy SD-WAN services, what's going to go at my locations? Typically, we're going to have a studio location, an office location, and typically we're going to have some transmitter sites. Maybe we'll have another studio in a nearby city or a faraway city. What am I looking at hardware wise?
So hardware-wise, you're looking at what we call an edge device, a device that will sit just behind your firewall router area. And what that's going to do is that essentially is executing the instructions from the orchestrator. So you've got your main office building that does all of your back office. You're going to have one there. You've got your transmitter station, maybe have one there. You may have 2 or 3 more remote studios. You have one there. And then once you have your orchestrator built, you can easily deploy these by just simply mailing them to location, power them up, and plugging in the network infrastructure. So now the orchestrator has an image of that internal network infrastructure in your brick and mortar, and then it also has a snapshot picture of your whole network as it's seen from the WAN from different locations. And so if you've got applications that are like Teams, which is what maybe your back office uses, or streaming applications, or you've got maybe an audio streaming application that lives at, I think if I'm recapping the scenario you gave me at the STL, at the broadcasting station, you can have access to those applications from any of those locations that are on your network infrastructure attached to that SD-WAN. But as far as devices, there is a device that is deployed on site at each one of the brick and mortars.
Okay. And again, that orchestration, I can control all this, look at everything, monitor everything, troubleshoot all that through what, some cloud application. Is that right?
Sure. So the orchestrator will more than likely be attached to a portal. So
okay.
Go ahead. I'm sorry, you had a question.
No. I was the orchestrator. Where does the orchestrator live? In a you said portal. Okay, would that be a cloud service?
Correct. So the orchestrator is a device that is owned by the provider, whether that is AT&T, Lumen, Verizon. I mean, there's hundreds of them, but they essentially own the orchestrator. So now you have access to your instance of the orchestrator through your admin portal. So think about it this way. Think about it if your family had 10 cell phones and you wanted to manage those accounts, maybe look up text messages and things like that. Ultimately, we all have a portal that we log in not only to pay, but we have a portal to log in to see where those phones. I need to track this phone down. It's got GPS or something to it. So that portal is very similar to the one that you have for your SD-WAN orchestrator. And that will tell you where all your edge devices are located. and what's connected to those edge devices. And even in some case, it go a little bit deeper to say what's going on in my internal infrastructure. I've got 5 laptops here. I've got, 2 access points here, and they're all hooked up to this ISP. And most of my traffic is going through ISP that's connected to WAN port 1. My backup is going to WAN port 2, which could be, again, diversifying your network, whether it's all physical, whether it's cellular or Starlink, or even you have a microwave, MPLS, VPNs. The SD-WAN can see that through a portal that is connected to the orchestrator that is hosted by the provider.
Ah, okay. And when you say hosted by the provider, we're not talking about the individual internet provider for a given site. We're talking about the SD-WAN provider. Is that right?
Correct. But your internet provider for a given site may have an SD-WAN practice. So
Gotcha.
let's just take like a Lumens or something, or a Verizon. We're agnostic to everything, but just for an example's sake, say, hey, I want to have internet. I need a 100 megabyte broadband here. I have 4 locations. I like to be able to see all of them at once. Do you have a software-defined SD-WAN solution? And 9 times out of 10, they say yes. Here's your circuit, and here's your SD-WAN solution deployed alongside with your hardware. And then now you have a portal that you can go to that you can check on the status, make any policy changes of your network as a whole. In some cases, there is something where you can do a Power BI. So your Power BI, which is just basically a proprietary knowledge base where your company goes to find different analytics or KPIs, you can do a connection to that portal to your own proprietary Power BI. So your information that you're getting from your SD-WAN looks like your company's front page or forward page. So there's multiple ways to get it. But the main thing is you have essentially an admin portal that is basically the front window to the orchestrator of your particular instance.
Okay. So I was just thinking about my own group of radio stations. We've got, I think, a total of 6 different internet providers in 7 or 8 different locations. And one of them isn't even a wired or fiber provider. It's just 5G internet. That's all we can get out there until we talk to Elon Musk, I suppose, if that's where we're going to have to go with it, because we can't get reliable internet any other way. So if my providers at all these sites are all different, and some transmitter sites have internet available, fiber internet, but other sites are simply going over an IP radio link. So I can have a single portal that aggregates all this information for me. Is that right?
Correct. So if I have a site and I have Starlink, I have an older MPLS, and I have, we'll use Verizon for now, and they have a terminator, like a cradle point for my cellular that connects into my network switch to give me internet to the outside world, I can connect that through my edge device. And now that information coming in, there's metadata coming in that will tell the orchestrator, oh, this is a 5G signal hosted by AT&T, or oh, this is a broadband that's hosted by Spectrum, or oh, this looks like something proprietary to a third-party application, which is actually really your microwave site going back and forth. It will determine what's connected in by connecting all of your, I guess, all of your WAN point or ISPs through that edge device before it gets to your switches and your routing. And then that metadata is hosted onto the orchestrator to where it says, all right, now I know the traffic. I'm running instances. I have communications of speed, bandwidth, average amount of data and packets going through. Now I can start pushing out policies. And now I'm looking through that edge device of the state of your ISP at that moment. And now I'm noticing trends. Now I'm noticing it's 5 o'clock. My broadband has slowed down, but my DIA is still constant. I'm online. I'm broadcasting voice right now. I'm going to send it down that pathway. Or let's say I'm running a broadcast and it's a late night broadcast. I'm listening to a jazz channel or something like that. 8 o'clock hits and all my backups start running. Now you're going to see the bunch of packets coming the other way. How do I make sure that these don't kick me offline, because now I'm maximizing my bandwidth? So maybe I'll say, all right, well, I'll send my voice traffic down pipe A, and I'll send my backup traffic down the slower one, because my backup's just going to run all night anyway. I need to have the speed and the availability now for my voice. So now the SD-WAN is going to do that on the fly without having to rely on rules that are in place for an on-premise router.
Okay.
If that's one scenario. Hopefully I'm describing that correctly.
Yeah, no, it's a lot of information to take in, and this is the second time I've heard a lot of this, and I'm still cogitating on this. Dan, good thing you've got you got smart people like Reggie to help you out when you're suggesting solutions for broadcasters and other companies, right?
Absolutely, yep. Great to have him. I wanted to also to further kind of demystify this for people, just to talk about who some of the underlying SD-WAN vendors are. So Cisco has two offerings, Meraki and Viptela. They purchased Meraki, I think, in 2012 and Viptela in 2017, something like that. So those are their two SD-WAN offerings. And then there's VeloCloud, which was acquired by VMware. And so all of the large telecoms, Verizon, AT&T, Lumen, they usually will offer several different flavors of SD-WAN. They'll offer Meraki, Viptela, VeloCloud, and a couple others. Big Leaf is another one people might know. Silver Peak, which I think was acquired by Aruba. Was it Versa that was acquired by HP? Is that HP? Reggie, do you know?
I don't know off
I'm
the
not
top of
sure.
my head. Let me dive
Yeah.
deep into that
So,
and see if I can get you an answer.
yeah, it's okay. Didn't mean to put you on the spot, but
No problem.
and so that kind of let's maybe segue from that into what we talked about a little bit earlier, Kirk, about deployment. People want to deploy SD-WAN or want to dip their toes in.
Hey Dan,
Do they
I'm
need?
gonna pause you. Dan, I'm gonna pause you for a second because we've lost your video feed, and that's why we haven't had you on switched on in the last few minutes. So I'm told by the producer you might want to hang up and reload that web tab and see if we can get your video back. And in the meantime, I want to talk to Reggie while we're waiting for Dan to reconnect. Reggie, I had questions about troubleshooting because at the moment when an engineer like me, let's say we lose some connectivity to one of our transmitter sites, I kind of understand, okay, the packets go through my router here and then through this internet provider, and then they go somewhere where they get mangled up to another internet provider, and then they make their way out to the transmitter site where they go through another router out there. But I kind of know what that process is, and I kind of know where to try to troubleshoot. Okay, where am I missing these packets? What's off? What's not working? How do I troubleshoot something going wrong? And we hope it doesn't, because now we may have multiple paths. But how do we troubleshoot things in an SD-WAN situation? What's our go-to to start troubleshooting?
So the first thing I believe is to figure out what. When I'm going to say what is wrong, but what I mean by that is, what pain point are you having? Have I lost connectivity? Do I have packet drops? Do I have jitter? Are a certain part of the world not receiving my broadcast for some reason? So I'm identifying what the problem is, which would be pretty obvious because that's why we're starting to troubleshoot. I always like to start from the application that gives me the most information. So that would be the orchestrator or your admin portal. So essentially, these edge devices, and for lack of a better word, it's going to have a heartbeat. It's going to say, all right, I reported in, I'm up, I'm alive, I'm good, I'm moving traffic. I log into my portal, I'm going to a location, and I know I have 3 different ISPs at that location, and I see a red light next to one saying this one is down. You're like, okay, well, looks like that my cellular is down, or it looks like my broadband connection is down. So now I'm going down the path and say, all right, the nice thing about, and each one is different. the orchestrator is different and the admin portal is different. So it may say this particular ISP is down. The provider is reporting an outage. Okay, I now know my orchestrator or my admin portal is reporting an outage for this particular provider. So it's automatically moving over to maybe my cellular or maybe my MPLS, whatever I have. If that doesn't show, maybe it will say, hey, oh, here's another one. There's extreme weather in the area. A lot of times portals will have reports one-to-one of weather that's in the area that's affecting outages. So that may be an issue. That will show. But if you do see a heartbeat there, maybe you can go in and you'll go to that heartbeat. You'll say, I'm still experiencing jitter. I see there's connectivity. Let's look at a log or an event log of the traffic going through there for the last 30 seconds, hour, a day. So back in the day, we used to go in when I was doing an on-site tech work and we wanted to troubleshoot that. We used to go in and place something or a device in software that was called Wireshark. And essentially, it was just sitting in your network, looking at data going back and forth, looking at trends. For your cloud-based unified communication provider or your cloud-based telephony, I can go back and look at the bit rate and the quality of a call and say, oh, this internet connection was slow, or I had quality go up here or drop here, or I had the speeds drop here. You can essentially do that for a snippet shot of data for that whole location. So now I'm going back in there and I'm saying, okay, my AT&T or my Verizon or whoever, they're not out, but I'm seeing large drops and large packet loss going through there. That's why it sent it through here. So now I'm drilling down that we're up and going. I'm passing data, not all the data. I'm getting losses. So now it's down to this ISP, or maybe it's a device. Maybe someone is passing some traffic. Maybe there's what they call, I call it rogue IT, but they can call it shadow IT. Maybe someone's got something in your infrastructure that is pulling data or doing something that you don't want to do, and it's slowing down bandwidth by sending packets in that has not been registered in the QoS or quality of service. You mentioned before, how can I make one set of data go before another? You can configure that in the QoS, but maybe the QoS on site, the router or the firewall on site, has been giving some instructions that don't necessarily drive with the orchestrator. And now you've narrowed it down to not the service, but maybe a device on site that's configured. So really, you're starting at the high point, and you're using your orchestrator to narrow you down to the solution to where it is either at something on location, whether it's a service, and even back to an application or a device that's plugged in on your network. Obviously, there's a lot more to it. There's things that I'm trying to put words and voices to that I just literally go in and feel and do. I'm sure everyone who's worked in the technical industry knows what that's like. But essentially, that's where you start. The orchestrator gives you your first look, and with the information it tells you, has you narrow it down to what's going on for each particular location.
Gotcha.
And
gotcha. Okay. Well,
I think.
yeah.
Oh, go ahead. I'm sorry.
No. You go ahead and finish your thought.
No, I think it's also fair to say that because one of the questions I get every once in a while is, well, what happens when the orchestrator fails? Well, that's the beauty of it, and it's the same thing as if a Teams, or the same thing if I'm trying to think of something that's a well-known cloud-based application or software as a service. The orchestrator is not set up in one place. The orchestrator is set up in multiple pods and multiple point of presences across the world, and its redundancy is if that goes down, we're probably in a lot bigger trouble than worrying about what's on the internet. So there's tons of point of presence. There's tons of pods that allow one instance to go down to do an update, and the other instance takes over, while you still have connectivity. So it gives you a high availability itself. So that's not a single point of failure.
Dan, I think Dan's back with us. Let's see if he is. Can we get a three shot?
I think so.
There he is. Yes. Okay.
Can you hear me? Okay, great.
Dan, I tell you
Yeah,
what, and
think,
I'm sorry. Wait, I'm sorry to put you off another 2 minutes, but I got to take a quick break because that's the way the timing works. Dan Merwin is with us, and I promise you, he's with us now. He's going to be back right after this commercial break, and Reggie Jeffrey is with us. Well, explaining SD-WAN, software-defined WANs. Several large broadcasters are moving more and more of their sites into SD-WAN connectivity to give them a real big overall picture of what's going on, to give them prioritization. And then there are other services that can be added on. Well, more redundancy, and then even some cyber security things and other stuff that Reggie will tell us about can be added on. We'll be back with Dan Merwin's comments in just a minute. It's This Week in Radio Tech. I'm Kirk Harnack here in the Nashville studio, the Telos Alliance studio here in Nashville, Tennessee. Our show is brought to you in part by our friends at Henry Engineering. And I'm so excited about this product. I just really believe in it. I bought 4 more of them for our Hawaii stations on Maui, and it's the Henry Engineering back UPS. Now, why? What? It's a simple, kind of a simple box. It's got some electronics inside to help make decisions, but really all it does is choose which AC power input is going to go to the stuff in your rack. Now, why do you need that? Well, at my stations, probably like yours, some equipment has dual power supplies. And that's great. By the way, would you ever plug dual power supplies into the same power strip? Probably not. You want them on different power strips. Maybe one power strip is UPS backed up. Maybe another power strip, it comes directly from your commercial power, or maybe it goes to a different UPS. Whatever the case may be, that's up to you. But you have with a server that with 2 power supplies, you have 2 sources of immediate power. Well, a lot of your equipment, even broadcast critical equipment, doesn't have 2 power supplies. You've got to create a redundant situation. And that's what the back UPS does. So I've got a whole rack full of gear that only has 1 power supply in each piece of gear. And yet they're all needed to hold stations on the air. So of course, the big power strip in the rack is backed up by a big UPS. But you know what? I've had UPSs fail. And maybe you have too. And also I've had times when I've had to take the UPS down to change batteries in the UPS or to do a test. It'd be nice if I didn't have to, depower all the gear in the rack. Well, that's what the back UPS does. For me, what I do is I plug in one input. In fact, it says right on there, input from UPS, and the other was input from the line or the commercial power without a UPS. And the back UPS is really fast switching between one and the other. So if your UPS dies, well, then it immediately goes to the line input. Oh, just like it's shown on the screen here in the lower right-hand corner. And it keeps your equipment that only has 1 power input. It keeps all that powered up. And then when the UPS is ready to come back online again, it'll, of course, switch back to that input if that's what you want. And you can control that delay time, anywhere from 10 seconds up to 16 minutes of delay time. Hey, is this UPS really going to be here? Let's make sure it is before we switch over. Now, this is not meant for your whole rack room. Each one of these back UPSs does about 15 amps of current. That's what it's rated for. And so, I've got mine running several computers, certainly not 15 amps worth. I probably have 7 or 8 amps on each of mine, but I've got 4 of these in 4 different racks in Hawaii. And I've got 2 of them in a couple different racks in Oxford, Mississippi. And I just love the way this thing works. Oh, it's got a remote on it. You can remotely force it to switch. You can also get a contact closer from it and run that into your remote control system to let you know, hey, guess what? I'm not on the UPS anymore. I'm on the commercial power. So wonderful product, very useful at your broadcast facility. If your UPS blips out for a second or a minute or whatever, I've had whole stations, groups of stations taken off the air by a UPS malfunctioning, and you may have had too. They're not as reliable as we like to think that they are. So having the back UPS from Henry is just a great thing to have. Where do you get it? Well, of course, you get it from Broadcasters General Store, BGS. The website is bgs.cc. bgs.cc. Love these folks. You can call them at 352-622-7700 and get your best deal. They got sharp pencils and good pricing, and and they can tell you when it's going to be delivered too. Easy shipping at Broadcasters General Store. All right. Thanks, BGS, for sponsoring This Week in Radio Tech. All right, now, finally, hey, Dan, are you still there?
I hope so. I need SD-WAN at my house so I don't drop any more video calls.
We all do. I got one source of interwebs myself, and it's not always there. So, Dan, what was it that you wanted to comment on?
There's a couple points. One is that you don't need to go through a managed service provider to deploy SD-WAN. You can do it yourself, buy the equipment and configure it and manage it yourself. Or you can have a co-managed model, which is pretty common, where the provider manages a portion of it and you still have some control. Or a fully managed model where you can let them do the whole thing. And of course, if you start out with a co-managed model and then you decide you don't really need to co-manage it, you can transition that to a fully managed deployment. But some go ahead. Well, one more thing I wanted to add was some of the providers offer some of the value adds that they offer is for example, like Cato, they control the middle mile, so the traffic runs between their gateways, so they can optimize that traffic, and then all of the providers pretty much now offer a cloud on ramp. So for mission critical latency sensitive applications, you can be via the SD-WAN provider. You don't need SD-WAN to have the service, but it's offered as part of SD-WAN service. Is you can be co-located with Salesforce or 365 or an infrastructure as a service provider like AWS or Azure, whatever applications you're running with them, and get that performance via a cloud on ramp. So those are some of the advantages you get by using a provider.
So yeah, I really hadn't thought about that. And it got mentioned during our SBE meeting. Help me clarify this. So I was thinking of SD-WAN at my physical locations, but indeed we have more services that may be living in the cloud. You're saying that I can extend my SD-WAN to that cloud location so that it's covered as well by this redundancy and other services available, right?
Absolutely, and wrap security services around that. Yeah.
Okay.
All with the one service.
I got a hardware question. So if I was just thinking about, okay, I've got, of course, routers at my different locations, and I happen to like my routers, but I'm not married to them. So if I put in an SD-WAN edge device, does that replace my router, or does that go like in between the router and whatever my WAN connections may be?
Throw it back to you, Reggie.
Most of the time, it doesn't replace your router, but certain providers do have an all-in-one solution that goes along with the service that you could, I don't want to say, well, I guess rent would be the best one for it. It's a part of the service. So now they've had a consolidated service. They've got your edge device along with your routing, or that the firewall device has a license to act as an edge device to talk to the orchestrator. So in that case, it would be an all-in-one. But yes, you can see both scenarios. You can have a standalone device. You can have a device that you can get from the provider that has a licensing for SD-WAN in it, like a Fortinet or a Meraki device, something of that nature that consolidates, that will do routing and act for instructions for your on-prem network solution. So you have the options of both. And normally with that might even be something that you want to own and just have the licensing for. In case you want to change a provider, you still have the hardware. You're just adding a different license that connects to a different provider for it. And that way you don't have to necessarily rip and replace if you're actually moving from provider to provider. So you can go either way.
Gotcha. Okay. Wow. That lot to think about. But the benefits, especially in it's funny, we come up with little solutions for problems that we have. So I'm not going to turn my camera and show it, but on a computer on a screen over to my right, I'm running a program called Multiping, and I'm pinging a total of 15 different sites that I'm either responsible for or part of. And just by graphing pings over time, I realized that's not the level of information that you get from your SD-WAN orchestrator. But at least I can see trends. Oh my goodness! Every evening at 7 p.m., that 4G gateway gets really unreliable when everybody starts watching Netflix in the neighborhood, right? And of course, by and large, sites that we have fiber internet, they're just on flat line, which is good. Always have the same ping time. It's always pretty reliable. But you can sure tell when things are getting ready to go off the air or may spell trouble, or maybe a gateway or router needs to get rebooted, and I have to call the station manager, in Mississippi and say, yeah, I need you to go to the station and reboot the gateway or something. So we've come up with all these different little, I call them piecemeal or patchwork solutions, whereas SD-WAN kind of, covers all this and more. Have I got that pretty straight in my head, Reggie?
Yeah, so SD-WAN has evolved. I think of it as it's evolved not because also because technology's gotten better, but the way we do business, the way we are day to day has changed. So when we talk about COVID, post-COVID, everyone has left the office. So I've left the office, I'm back at home. So now my users are all over. When we look to see about, okay, what kind of SD-WAN solution, why do you need it? What problems you're asking? The three main questions I'm asking are, where are your users accessing these applications? Where do those applications live? And what applications are they? Do they need high latency? Do they need, can I go with something with a high latency, or do I need something with a low latency? Does most of my people live in Dallas, but the data center is all the way out in Michigan or something like that? I need to bring that data center closer to where my people work so the latency is lower. And I need to have connectivity because now we're all everywhere. We're working from home or we're on the go. We're internationally working. So now SD-WAN says, okay, to Dan's point of saying earlier, not only do I need to have connectivity and redundancy, Microsoft has a presence here where my people are. This is the closest data center. I need my connectivity to have a direct connection to that's close for my people so I can have better connectivity. Maybe, and that's where we go into what kind of software applications are you using? Are they near to where your people, and now do they meet the services and reaction time and what your people need? When we talk about security, now we have people who are working remote. We have cybersecurity issues. We want to make sure our data is protected. If data is like money and it has value, you protect your money, you put it in the bank. You protect your data, you put security around it. So if I have a VPN scenario, I may be able to VPN into my corporate server, but once I VPN into my corporate server, unless my group policies are set correctly, I can go anywhere I want from there. Maybe I don't want that. Maybe I want whoever is in the admin department to only have access to admin files. Or maybe I only want my Michigan team who only does, who's my doctor.
Oh, we lost Reggie's audio.
Yeah.
Not sure where that went to. Reggie, I'm sorry. We lost your audio.
Got it back.
Where does it? Hopefully I've been talking the whole time and it just went away.
No, just a few seconds.
It's there. It's there. Yeah, just a few seconds. Go ahead and finish your thought, Reggie. Yeah. That's fine.
So maybe I have a group of doctors or whatnot who are the only ones who should have access to HIPAA compliant information. So maybe I create what's called a zero trust network access protocol that gives those doctors a direct path to those files on that infrastructure and nowhere else. And not only do they have a direct path, but I can also monitor, get KPIs, get analytics of who's going where and what, report to my security team about the ins and outs of what's going on with those files. So SD-WAN allows you to put that network security infrastructure over that at a wide area access network level and not a local level, and control from one single point. So SD-WAN has grown in its capabilities to meet our business needs and how we work today.
Okay, so I got a scenario here. Need a quick answer from either Dan or Reggie. I have a company that has a rather interesting business model. We do stock trading. We have players who are world champion Halo players. We do online dating, and we provide FTP services. What gets the best priority?
What gets the best priority?
Yeah, which should we give the best priority to?
Probably the
I'll
stock
let you
trading.
answer that question first, Dan.
The stock trading? Okay. And
Seems
Halo
to be.
gets the second priority? Yeah.
I would say whatever makes me the most money at the given time. That's the one that gets the
That's right.
priority.
Well, Reggie, I couldn't help but notice your PS5 there in the background. So I'm sure either you or the kids play with that from time to time.
A little bit, a little bit. There's a whole gaming story back there. You brought up esports. That's a whole nother story for another time. But yeah, completely get where you're coming from. It's there.
I saw a meme recently about a guy who bought a PS5, but he put a TP-Link label on it and told his wife that they needed a new router. That's why he bought it.
That's genius.
That's genius. Hey, guys, we got one more quick commercial break. And when we come back, I need a tip of the week from one or each of you coming up. And so you've got 2 minutes to figure out a tip of the week to leave our audience with. This Week in Radio Tech is brought to you in part by Angry Audio. And my little favorite thing that they're doing right now is the Rave console. This is, it's an analog console. It's not audio over IP. It doesn't have USB connectivity. It is an analog console, but oh my goodness, what a beautiful little console this is. Well built. This is going to last. This is going to last the rest of your radio or content creation career. I promise you. This thing is built like a freaking tank. I hope it's okay with Catfish if I say that. It's heavy. It's made of steel, bottom, and I think the top is steel too. The labeling is all laser engraved, so it's not going anywhere. It's going to look good for the rest of your life. 2 mix buses, 4 mic inputs. It's got 8 line inputs. You can switch, line mic on some of those inputs. It has a mix minus bus for your codecs or your telephone hybrid. Of course, you can put it in any channel in preview. For hooking it up, look at the back. It's got Studio Hub connectors. Of course, it also does have XLRs for your microphones, because most people prefer those. But Studio Hub connectors make this thing fast to connect and hook up and get it involved, put it into your studio. This console is absolutely gorgeous. This thing was actually a couple of years in the design and manufacturability, and now it is shipping. It's been shipping for almost a year now. The Rave console from Angry Audio. You buy this console, you're going to be happy with it. I promise you. It's just perfect for podcast studios, any place you need an analog console that is very well built and, of course, sounds great. From Angry Audio, go to angryaudio.com to find out more about the Rave console. Our show is also brought to you by Max Connect. They do a lot of things for broadcasters, including some on-site engineering services or consulting services. But one thing that they do is the Max Connect wireless. And here is John Takach to tell you more about that.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
I am so glad that Josh Bone took the trouble to research this and then execute and make it happen to give broadcasters like you and me 4G LTE wireless that also is prioritized data. That means you can be next to a stadium. You can be in the stadium with 60,000 people all updating their Facebook page at the same time, sucking up all the bandwidth. And guess what? You still have dedicated bandwidth with Max Connect. It's really awesome. They keep updating their services and what's available, and their new service that gives you satellite backup or gives you LTE backup to the satellite, whichever is going to be better for your situation. Check it out at maxconnect.com. TWiRT.com. There's a link in the show notes. I know it's spelled funny. Yeah, so click the link in the show notes. Thanks a lot, Josh Bone at Max Connect, for making this product possible. All right, we've got just 3 or 4 or 5 minutes left, so let's get a quick tip of the week. Dan, would you like to start first and maybe leave us with some good advice?
Sure, and it's kind of a sales pitch, so I apologize in advance. But don't trust that your telecom bills are correct. If you speak to anyone that's been in telecom for a long time, then they'll tell you that they've seen so many examples of people who are paying for services that they haven't used for years at a location that they haven't been in, or they're paying for things that they're not using, or the rate has changed, but the provider hasn't changed their rate per the contract. So give me your bills. I'll look at them for free and see what I can do for you.
Awesome. That's great. We'll have your contact info link in the in the show notes. And so often this happens, because engineering and the accounting department don't talk to each other too much at a lot of broadcast facilities. And, something can change. Service is no longer used. It didn't get canceled, or you canceled it, but guess what? The bill kept coming. So thanks, Dan, for pointing that out. Stations can save a ton of money by auditing those things. So thanks a lot. Reggie, looking for some advice, a tip of the week from you.
Well, he must have been in my mind because that's where I was going. So I had to quickly pivot. I was going to say, check your billing. But he's already there. So that's perfect.
Great minds
So
think
mine
alike.
is going to be absolutely. So mine is going to be just a general tip is if it's you or your IT team, ask them when's the last time we've checked our backups? And I mean data backup or solution backups. When's the last time? Not do we have them, but when's the last time we tested them? Because if those aren't in place, then probably something else isn't in place, and then something else isn't in place, and you're pretty vulnerable. So cybersecurity awareness is at an all-time high right now. The government's making a lot of changes. The world is becoming smaller through the internet. AI is doing a lot of different things. So check your backups, because if those are in good states, it's a good chance that maybe everything else is too. But that's a good place to start. See if those are working, and then dive deeper into your cyber solution.
Great advice. Oh my goodness. And I must say that very fortunately, and I love this. I know they're one of our sponsors now, but Playout One has this application called Monitor that runs. And if you've got offsite backup set up through Microsoft Azure or Google Drive, if that's not working, it'll flash a red light up and say, hey, you set this up and here's something wrong. You need to reauthorize or whatever, or you're out of space. So I love it when things tell me that there's something wrong, but you know what? Most things don't tell you. So you got to go check them. Right. Right. All right. Reggie and Dan, we got to go. I appreciate so much you spending over an hour with me here on This Week in Radio Tech. It's great to reconnect with you, Dan, and Reggie. Great to get to know you. Now I feel like I've got a friend in the SD-WAN business, and I've got a gateway to him, and that would be Dan.
Right.
Good to meet you. Thanks for having me.
Hey, and don't hang up, because when the show's over, Suncast takes pictures. So we'll take a picture of you in just a minute.
Right.
Big thanks to Suncast for producing today's show. Thank you for your technical expertise, Suncast. I really appreciate it. And we got to go. We're going to see you next week on This Week in Radio Tech. Bye-bye.
Thanks for having us.